Hello, this is Jalen Toaston. I am recording my second video for project number 2 for Dr. Ishmael and Mechatronics for Southern University. The first initial step that we had to take was downloading the correct program software, which is Python. Now, as displayed here, this isn't the exact program, but this is the website you have to go to in order to get the correct program to download. So hence, in doing that, this is what we will be using here, which is NumPy 2.1.1. This is what will be used in order to get the correct values for the matrices in the program that we will be using and displayed in the video today for you. Now, the only issue you may have is you would have to research it and make sure you're downloading the correct file, which we did struggle with initially, but we were able to find it, and you might have a couple error messages as well displayed in the program. So when you're able to find that out, you will then be able to know, oh, this is not the correct program. So we have to make sure we have the correct one downloaded as displayed here. So now I'm going to transition over. Oh wait, before I do that, this is also like the HTML files as well. This is just displaying where, like, whenever you download the NumPy 2.1 file, where you have to go in order to make sure it's downloaded to Python as well. You will go through these. You have to click on Site Packages, which is here. You would then click on NumPy, which is displayed here. And it will show you all the files that you would need to have. But in the video, it will display and it will show us which ones we had to use in order to get to that point. Right. We will now transition into the software, which is the program. Starting here, this is the program here. Let me expand it a little bit for us. Okay, so this is the program that we are running here today. This is the NumPy 2.1.1. Starting off, you can see here, this is import NumPy as NP. So what that starts for, that is the numerical computation symbol initiation for the Python. So initially, this will be able to help us use the sine and cosine factors that are in the program as well. As you can see here where the mouse is, this is the theta 1, theta 2, theta 3, theta 4, theta 5, and also the theta 6 in degrees. That there will allow us to initialize the angle of each joint, and this will also determine the rotation, which is the sixth degree of freedom in this specific section of the program as well. This is just displaying like how the angles that we will be using in degrees as well. Now here, the second part, the theta 1 here, that is theta 1 divided by 180 degrees times the NP pi. That is, this section is using the program to be able to convert from degrees to radians using the trigonometric functions in Python. Because if we were to use this and we were doing it by hand, it would take us a little bit more time and make it a little bit more tedious, and the work itself would be really time consuming. So we use Python in order to get the factors and data correctly and also be more efficient as well. That's what that's for. So this next section here where the mouse is, the R theta underscore 1 through 6, that is the matrix that represents the rotation of the first joint. This is what we were talking about when I said this program for the NumPy part as well. Back up here, the import NumPy as NP. NumPy is going to be using the sine and cosine terminology factors as well. This is why you see sine, negative sine, the cosine, the negative sine, and you could also see the T1, the T2, the T3s, the T4s, including the theta angles as well. So that's what we'll be using in order to be able to calculate and represent the rotation of those joints. The R2 down here, NP dot, those are used to calculate the rotation of the matrices, but that's going from 0 to 2. So in an instance like this one, it will be going from 0 to 4, 0 to 6 as well. Those are also it's really implementing the same steps as it did before from the original R0 underscore 1 factors. Also going into the R04 as well. It's just calculating those values and those numbers as well. So that's what we like to account for in the program. Lastly, coming down here at the bottom of the program, which is the print area, these lines will print out the individual rotation matrices for the final rotation matrix. that's going to be formatted in the matrix form, which I will display when we run the program. So basically, this is just initializing the program and telling us what is going to be what values will be where, making sure that it's correct and our values stay consistent and we don't have any miscalculated information. Starting here, as you can see, all these values are zeros. I'm going to now run the program so you can see the matrices from that point. Here we go. So as you can see here, this is rotation matrix 1, rotation matrix from 2 to 1, rotation matrix from 3 to 2, 4 to 3, 5 to 4, 6 to 5, and going all the way to 0 to 6. This is 0. As you can see here, all these values are coming in through the matrix as 1, 0, 0, 0, 0, 1, 0, 1, 0. Of course, they're differently depending on which rotation you're using. But also in this factor, this is what we would be using in order to make sure that we're measuring the correct values across the rotation matrix as well. So now I will go back into the original code. I will now change theta 1 to 90, and I will change theta 4 to 90 as well. So now this is going to give us different values because we're changing the theta points, the theta values in the degrees as well for these specific points. So now I'm going to display the matrices. We'll hit OK. And so now we have different values here. Now we're getting natural log and things of that nature here. The rotation matrix across 1 is a little bit different here. Rotation matrix across 2 is a little bit different. 4, a little bit more of a drastic change here as well, because remember, as stated before, we changed the values from theta 1 and theta 4 to 90. Now we are processing that information. Also, as you can see here, rotation matrix 6 right here at the bottom, including those two values from theta 1 and 4. Those are the conclusion values for those. And this will conclude the display of the Python, including the matrices and the NumPy program used in order to get these values and the showing and displaying the matrices. Thank you and have a great day.